All right, today we're jumping into one of the biggest questions you can possibly ask, a question that sits right at the intersection of physics and philosophy. We're talking about the origin of the universe, how science has tried to explain it, and maybe more importantly, how that explanation is starting to change in a pretty dramatic way. So here it is, the core question. Is there room for God in the Big Bang? For a long, long time, it really seemed like science had a solid, definitive answer to that, and it came from one of the most brilliant minds in history. And there's the statement from the one and only Stephen Hawking. It's an incredibly powerful conclusion that, for a lot of people, basically settled the debate. But what was his reasoning? How did he get there? And the bigger question for us today is that still the final word?
To really get what Hawking was saying, we need to dive into the physics he was working with. See, this wasn't just a philosophical stance for him. It was the logical endpoint of a framework we can call the no-time problem.
Hawking's logic wasn't just pulled out of thin air. Nope, it was built on the absolute bedrock of modern physics, Albert Einstein's general theory of relativity. The theory that completely changed how we see gravity, space, and time as all being woven together. So, according to Einstein's theory, the classical way to look at the Big Bang is to see it as a singularity, a single instantaneous point where everything, and I mean everything we know, including space and time itself, just exploded into being. Okay, so let's just follow that logic for a second. If the Big Bang was the absolute beginning, a single, one-time-only event, then you run into a huge problem. You can't have a creator acting before time exists if the Big Bang is what created time in the first place. For Hawking, this was an open and shut case. There was literally no opportunity, no moment for God to create the universe. Case closed. Or was it? And this is where the story takes a really fascinating, unexpected turn. That classical view of the Big Bang, as powerful as it is now being seriously challenged by a whole new perspective, one that comes from the super strange and counterintuitive world of quantum mechanics. So, is that classical, instantaneous Big Bang really the only way to understand creation? Well, a growing number of physicists today are saying not so fast. In fact, a leading physicist, Michio Kaku, goes so far as to call Hawking's classical model an old theory. He's arguing that, hey, science has moved on, and our whole understanding of where the universe came from has evolved right along with it.
And this, right here, is the fundamental shift. The new way of thinking isn't based on classical physics anymore. It's based on quantum physics, the bizarre rules that run the show at the subatomic level. In this new view, the Big Bang wasn't a classical event. It was a quantum one.
Now, thinking of the Big Bang as a quantum event doesn't just tweak the old theory a little bit. Oh no, it completely blows the doors wide open to a truly mind-bending possibility, the multiverse. So, what's the big deal about a quantum event? Well, here's the key difference. In the quantum world, if something can happen, it will happen. And not just once, but repeatedly. It's a fundamental part of the whole theory. So you can see how this logic builds, step by step. If the Big Bang was a quantum event, then, since quantum events can repeat, that means new universes can be created. The stunning conclusion is that our universe isn't some special one-off thing. It's just one of many in a vast cosmic ocean, a multiverse. And we're not just talking about a handful of other universes. The theory suggests a potentially infinite sea of them, each one bubbling up into existence. The scale is just, well, it's pretty much impossible to wrap your head around. So, where does this giant quantum leap leave us with our original question? It doesn't exactly give us a simple yes or no answer, but what it does is completely change the entire framework for how we even ask the question in the first place. Seeing them side by side like this makes the difference crystal clear. You've got Hawking's classical view, one universe, an instantaneous creation, and no time before it. Then you have Kaku's quantum view, a multiverse, a repeating creation, and, crucially, plenty of time for a creator to exist outside of our universe's timeline. So really, the key takeaway here is that the science has evolved. The conversation has shifted from a single, isolated event to a potentially endless cosmic process. The very canvas that we're using to ask this profound question has become infinitely larger. And that leaves us with a brand new and maybe even more profound question. If creation isn't a single moment that happened once, but a vast, ongoing, potentially infinite cosmic process. What does that mean for the idea of a creator? This shift forces us to rethink everything we thought we knew about the beginning, and maybe about the beginner.